want to talk about the physics of the perfect pour. You like fries, right? So you like ketchup on fries, but you couldn't pour it in the right amount. So here's the way. The dinner table paradox: solid or liquid? The solid, if you make feel of solid steel, it could just look like it, no matter how you shake, how you throw it around, it doesn't pour out a single one. But if you think of another one is liquid water, it pours down like a drain, like a waterfall. But ketchup, the anomaly. How with violent shaking it's too hard, but it could pour out after a few shakes. The law of bidding fluids, like water, oils, and alcohols. The faster you push, the more it flows. The faster it flows. Sir Isaac Newton of Apple fame first proposed this linear relationship. So that means they are Newtonian fluids. Fluid dynamics. In the kitchen, rules versus rebels. Newtonian, the rule followers. They look like from oils and alcohols. The sheer thinning, the line of rule breakers. Ketchup, mayonnaise, toothpaste, paint, and blood. There are two ketchups here, so don't count the second ketchup one. Mechanic, the sheer thickening. The opposites. Oobleck, natural peanut butter. Ketchup is non-Newtonian in two distinct ways. Victor A. Path, the force threshold. Push hard enough, it suddenly becomes 1,000 times thinner. It looks like. And second, the Victor Path beat, the time threshold. Pushed weakly for a long time, and it eventually escapes its glassy prison. Breaking point number 1, the force threshold. Weak force behaves exactly like a solid, zero flow. But after that, if you push it harder, it will be like the particles bump together, and sometimes they even squish together, so they became a liquid to flow out, escaping the glassy prison. High force applied. The time will be very fast, but the low force is just look like very. The autonomous. You couldn't know what happens if you push slowly from the ketchup to pour down. One says that the ketchup particles will go together. The tomatoes look like utterly destroyed tomatoes. The soup, mostly water plus vinegar, sugar, and spices. The weak force applied quickly. It looked like they bumped into each other, while the strong force, they became thin ovals or something else. The mystery of time and lubrication. Hypothesis 1, lubrication theory. Particles get bumped toward the middle, leaving a mostly the mostly watered soup near the edges to lubricate the glass. Hypothesis 2. Rearrangement theory. Particles slowly rearrange into small groups that flow past each other. Scientists are still actively researching this one. The chaos variables. Why every bottle is different. Ring 1. The base soup balance. Exact rations of vinegar, water, and spices. Ring number 2. Polarized tomato density. Volume and shape of cellular remains. Number 3. Satan gum. The natural thickener, also found in milkshakes and fruit drinks. It presents means two different ketchup can behave completely differently. But synchronizing the physics of the pour, you could take the action short sharp spin the macro waking up the pro way is like tapping it for a few times, and then it will wake up the particles, and you fall down instantly drops through the heavenly fries. Step 1. Keep the lid on. Second, short soft shakes like tapping the to wake them up. Number 3. Remove the lid. And number 4. Control the pour. Gravity takes over. Apply a precise threshold to wake up the tomato particles, resulting in a heavenly delivery onto your fries. Okay everyone, that's all for today. Goodbye guys.